Welcome to a new season of Nova Science Now. I'm Neil deGrasse Tyson, astrophysicist and your host. In each show, we'll bring you several stories, breaking news from the frontiers of science. You'll meet my fellow scientists exploring the universe, from the tiniest microbes to the farthest reaches of the cosmos. First, let's take a look at our own solar system. It can seem like an orderly place, where the planets chug along in their orbits like trains on a track. But there's no guarantee those tracks will remain clear, because in addition to the planets, there's a lot of other stuff in the solar system, and eventually their paths will cross. Now, if you happen to live on one of those planets, that would be bad. One night in 2004, telescopes spotted a tiny dot moving across the sky. That dot was actually an asteroid named Apophis, and it seemed to be headed towards Earth. When seen even through our most powerful telescopes, Apophis shows up as nothing more than just a moving speck of light. But the latest data tell us that this asteroid may be as wide as 1,000 feet.
That's bigger than the Rose Bowl.
Now imagine that hunk of rock hurtling through space on a collision course with Earth. It sounds like something from the movies. Remember Deep Impact? Or Armageddon?
Rise and shine!
Where Bruce Willis saves the world? The movies were a little silly. Somehow all the flaming fragments in Armageddon had good aim and hit only famous buildings. But they were inspired by a basic and frightening truth about our solar system. It's easy to think of the solar system as a big, wide, open playing field. The sun in the middle and just a few planets in orbit around it. But in fact, between the planets, it's filled with debris. Of all sizes, some as small as a pea, others as large as cars, houses, even mountains. We've been hit before by these things. And you know something else? We're going to get hit again. In space, they're just cold hunks of rock. But when they plunge into Earth's atmosphere at 30 or 40,000 miles an hour, their surface glows red hot. Small objects will burn up before hitting the ground. We call those shooting stars. But the bigger ones will keep on coming and explode on impact. If you know where to look, you can see the damage caused by past impacts all around us. Our moon is scarred with countless craters. Here on Earth, this mile-wide hole in the Arizona desert was blasted by an asteroid as big as an office building. And 65 million years ago, a rock the size of Mount Everest slammed into the Yucatan. That's the one that triggered the demise of the dinosaurs. Our long history of getting in the way of asteroids worries Apollo astronaut Rusty Schweickart.
I mean, an asteroid can literally destroy 80 or 90% of the species that are alive on Earth. These are big events. I mean, this is called extinction.
To guard against catastrophe, a team at NASA tracks asteroids, including that potentially lethal one, Apophis, named for an Egyptian god of darkness and evil.
It was clear that it was going to be a very close approach and fascinating object.
In late 2004, with just a few observations to go on, the team came up with a scary prediction.
Very often, they start at 1 in a million, maybe even 1 in a billion. In this case, the maximum probability was about 1 in 37.
1 in 37 chance that in April of the year 2029, Apophis would slam into Earth on, get this, Friday the 13th.
Never seen anything like that before. That was absolutely extraordinary.
Extraordinary indeed, but not necessarily right. The NASA team has to continually revise its predictions.
It's much like predicting a hurricane. When it's first spotted, you don't know where it's going to hit. As you get more and more information on its track, you can predict where it's going to go.
It turned out that Friday the 13th, 2029, wouldn't be so unlucky after all. Apophis will not hit us that day. But the asteroid will come frighteningly close to Earth.
It's going to come 10 times closer to us than the moon is. So it's actually going to pass closer to us than the ring of satellites, communication satellites that are in synchronous altitude around the Earth.
Such a near miss means that Earth's gravity will dramatically alter the asteroid's orbit. Problem is, as its path bends, there's one small region of space we do not want Apophis to pass through. Chodas named it the keyhole.
If it should pass through that little keyhole, then it would be on a collision course at a later encounter. Now, if I advance it after 2029, you can see...
If the asteroid passes through the keyhole, then 7 years later, in 2036, Apophis will be headed right for us. So what if that one possibility actually happened? What kind of damage could an asteroid the size of the Rose Bowl do?
If Apophis did impact, it would impact at around 7.5 miles per second. And all that energy has to go somewhere. It would leave a blast area of around 60 to 100 miles across. And it would dissipate energy about equal to 100 nuclear bombs going off at the same time.
An asteroid the size of Apophis, if it hit land, could devastate several counties in, say, Southern California. But if Apophis passes through the center of the keyhole, it will slam into the Pacific Ocean, nearly 1,000 miles off the California coast. And that could be a lot worse.
If it hits in the ocean or in the water, it's going to create a very significant tsunami.
I met up with Rusty Schweikert to find out what that tsunami might do to Santa Monica Beach.
We would have 3.5 hours of waves 55 feet high and larger crashing onto this shore.
So not just a simple rise in the water level that we saw in the Indonesian tsunami.
Right.
You're talking about a surfable wave.
That yellow building will be gone.
So it's basically going to chew its way into the coastline.
It's going to sandpaper the whole coast all the way up and down from the Panama Canal all the way up to Alaska.
So if this or any other asteroid has our name on it, do we just run for our lives? Or could we actually do something about it?
Unlike any other natural disaster, especially the big natural disasters that we know of, this one, if we use our brains, we can prevent. We don't just prepare for it. We can literally stop it from happening.
What you're saying is we don't know how to turn off a volcano yet. We don't know how to undo a hurricane.
That's right.
This is one of the great natural disasters that we have the power, the knowledge, the means of avoiding. In the big asteroid movies, the solution always seems to be the same. Send up some action heroes,
God be with you,
and nuke the thing.
That's a very, very bad way to try and deflect an asteroid that's headed for the Earth. You're going to certainly have a lot of debris. So that stuff is going to end up hitting the Earth anyway. You don't know what's going to happen.
But if nuclear weapons aren't the best defense against asteroids, what is?
If it's a small object, you could simply run into it, slow it down or speed it up so that in 20 or 30 years, when it was predicted to hit the Earth, it would be slowed down just enough that it would miss the Earth, or sped up just enough that it would miss the Earth.
Just recently, NASA slammed a spaceship into a comet. They weren't trying to deflect it, just study what it's made of. But before you could successfully deflect a hunk of rock like Apophis, you'd have to know its exact shape and structure. Lance Benner studies asteroids with radar by bouncing radio waves off the rocks.
Radar imaging of asteroids has revealed a completely bewildering zoo of different shapes and sizes. We see objects like this one that's roughly the shape of a cucumber. We see many that look like potatoes. We're seeing a surprising number that are actually spheres.
There's even one that looks like a dog bone. And what about Apophis?
We know very little about Apophis, unfortunately. We have a crude estimate of its size. We don't know anything detailed about its shape. We don't know if it's a porous object.
Deflecting a weirdly shaped or porous object would be a challenge. A more flexible solution might be a gravitational tractor. The idea is, send an unmanned spacecraft up to the asteroid and have it fly just ahead of the rock. Then, the spaceship's gravity can, over time, work to subtly change the asteroid's speed, putting it on a slightly different orbit.
If you use a gravitational tractor where you're pulling it using gravity as a tow rope, you know precisely what you're doing and what's happening to the asteroid all the time.
For Rusty Schweikert, the consequences of failure are so dire, he believes NASA needs to demonstrate this technique now.
I think the world public is going to want to know for certain that something is going to work when you go up and try to, deflect an asteroid from wiping out life. They're not going to want to hear a bunch of scientists say, well, we think it'll work, or it's 80% probability, or 95% probability. You're going to want to know.
So, out of all of those cases...
Not everyone thinks we should be spending a couple of $100 million on a deflection mission anytime soon.
I'm of the opinion that the majority of the resources that NASA is devoting to this effort should be in searching for these objects and finding them early, finding them early.
We know of about 4,000 near-Earth asteroids, but recent estimates tell us that there's thousands more just as deadly that we have yet to discover.
An object like Apophis is just the tip of the iceberg. So my concern is not with this individual object. My concern is the tens of thousands of these objects that we haven't yet discovered and that could take us by surprise if we don't discover them.